Hello and welcome to our second video on our series on Pythagoras. I'm Mr. Chowdhury and today we're going to be looking at finding the missing side of a right angled triangle using Pythagoras theorem. Now if you haven't already watched our first video, I suggest you go and watch that so you can understand where Pythagoras comes from, and once you've done that you can come back and watch this video. So here is your first task. Your first task is to look at these two sets of working that I've got here. What's the same and what's different? And then if you're confident that you've figured out all of the similarities and all the differences, what I'd like you to do is write down why you think we're doing each step in the working. Right? So what we're going to do is tell me what's the same, what's different, and then why you think we're doing each step in the working. So pause the video and have a go at that, please. Okay, so before we look at any of the working and why we're doing it, let's have a look at the similarities and differences. So both triangles are right angled. We know that. Both triangles are using Pythagoras. We can see that we're using Pythagoras in both triangles. I've got a squared plus b squared equals c squared on the left hand side, a squared plus b squared equals c squared on the right hand side, and we know that's what Pythagoras theorem is. What else do we have? Let's have a think. So the base of these two triangles is 4 centimeters. So one of the lengths is 4 centimeters on both of them. We've got that one. On the left hand side, this height here is 3 centimeters. And then the missing side, the hypotenuse, is 5 centimeters. Over here, the hypotenuse is 5 centimeters, and the missing side, which is the height, is 3 centimeters. So because their lengths are 3 centimeters for the height, 4 centimeters for the base, and 5 centimeters for the hypotenuse, similarly on the right hand side, 4 centimeters for the base, 3 centimeters for the height, 5 centimeters for the hypotenuse, we can say that these two triangles are exactly the same. The only difference between these two questions is on the left hand side we're looking for the hypotenuse, and on the right hand side we're looking for the height, or a shorter side. Okay, so now that we know what the similarities and differences are, we can look at why we're doing each step of the answers. So the first thing that they've done on both of these questions, is label the triangles correctly. So the key thing to do is label the hypotenuse correctly. So in both of these examples, the hypotenuse is labeled correctly. I've got my right angle, opposite the right angle is my hypotenuse. I have my right angle, opposite the right angle is my hypotenuse. They have then labeled A and B. It doesn't really matter which way you label A and B, because we're going to end up doing the sum of A squared and B squared, because we're going to end up doing an addition, and addition is commutative. It doesn't matter which order we do it. Now commutative means we can do it in whatever order. So for example, 3 add 4 is the same as 4 add 3. Obviously we have to square them first, but you get the idea. So let's have a look at the left hand side working, and we'll go from there. So both of them are using the Pythagoras theorem, which is fine, and for both of them we've substituted the values in both. Now on the right hand side we've had to rearrange to make x the subject, whereas on the left hand side we haven't. Because if we look, we have a calculation equals x squared, and over here we've got x squared plus something equals something else. Right, so here we've got x squared plus 16 equals 25. X is not the subject of this equation, whereas on the left hand side x is the subject of this equation. You could say x squared is equal to 9 add 16, whereas here we would have to do an extra step to rearrange this equation. So once we've rearranged it, we need to make sure we square root the answers. So over here on the left hand side, to get from x squared to x, because we don't want x squared, we want to know what the value of x is, so we need to square root it. So we need to do the same on the other side. So we square root 25 and we get 5. On the right hand side we do the exact same thing once we have rearranged the equation. So we can see from this a very key thing that we need to take away. And the key thing in both of these examples is that when we are looking for a shorter side, we need to rearrange the equation. When we're looking for a shorter side, we need to rearrange the equation. When we're looking for the hypotenuse, we don't have to do any rearranging. The other key thing is, to get the answer, we need to square root whatever we have. Right? If we don't square root, we just end up with the square. We don't want the square, we want the length. So we need to square root the answer. So now we're going to try and apply what we've just learned about Pythagoras theorem to a question and see if we can answer this type of question. So here's our first question, and I've got this triangle and I've got some labelled sides and I'm missing a side. So the first thing I'm going to do is label the triangle to look for the hypotenuse. So I need to label the triangle so I can find the hypotenuse. So I've got my right angle, I look directly opposite that and I label that side C because that's my hypotenuse, and then I label the other two A and B. Now it doesn't matter which way around we do it because we're going to add them anyway. And addition is commutative, which means the order doesn't matter. So for example, 6 add 4 is 10, 4 add 6 is 10. The order doesn't matter. Multiplication is commutative. So the way we write A and B, the way we label A and B, does not matter. Now that we've done that, we're going to write down Pythagoras theorem. And just a reminder, Pythagoras theorem is a squared plus b squared equals c squared. That's the traditional way of seeing it. That's how you're going to see it if you look for it online. However, the way we want to remember it is what it actually means. And it means the square of the shorter sides, sum, add, to give me the square of the longest side. So I need to remember I'm squaring all of the sides. So now that I've got Pythagoras theorem, I can substitute in my values. So I've substituted in my values. A is 21 and B is 20. And remember, I need to square both of these. And C is equal to X, and I need to square that. Once I've done that, I need to think to myself, well, do I need to rearrange anything here? Just to give me an idea of do I need to rearrange anything here. So I don't need to rearrange if the unknown, the thing I'm looking for, is the subject of the equation. Now let's have a look at this calculation. This is X is the subject of this equation, because 21 squared plus 20 squared equals X. X is on its own on the right hand side. It is the subject of this equation. So now that I know that it's a subject and I know I don't have to rearrange anything, I can start doing some calculations. So I'm going to do 21 squared and 20 squared. So I get 441 plus 400 equals x squared. Then I continue with my calculation. I get 841 equals x squared. Now I don't want to know the value of x squared. I want to know the value of x. So if I'm squaring something, the inverse operation to squaring is square rooting. So I need to square root both sides of this equation. So I square root both sides and I get x is equal to root 841, and I can pop that in a calculator and get an answer, and I get 29. So x is equal to 29. Okay, so let's have a look at another example. So this time it's the exact same triangle, except we're missing a different length. So we're going to do the same steps again. The beginning of each of these questions is always going to be the same. We will label our triangle. There's the right angle. Opposite the right angle is our hypotenuse. I label that C. The other two sides don't matter, so I label them A and B. I write down Pythagoras theorem. So there I am, writing down Pythagoras theorem. I then substitute my values in. This time B is X. So instead of a number, I write X. A is 21 and C is 29. So I've written that in. I need to now ask myself, well, is X the subject of this equation? It's not. So at some point I'm going to have to do some rearranging. So let's have a look what I do next. I then do some squaring. So I've calculated the square of 21. So I did 21 squared. I've calculated the square of 29. So I did 29 squared. I've done that. Once again, X is not the subject, so I have to do another step. So to make X the subject, I have to subtract 441 from the left hand side, which means I'll have to do the exact same thing from the right hand side to keep the equations balanced. So I'm subtracting 441 from both sides. So I get X squared is equal to 841 minus 441. Right, 841 minus 441. So X squared gives me 400. Now that's not the answer to this question, because I don't want to know what the value of x squared is. I want to know the value of x. Don't want to know what the value of x squared is. I want to know the value of x. So what I do from this point is I square root both sides, just like I did in the previous question, and I get my answer of 20. Now, hopefully that's given you a really good idea of how to apply Pythagoras to find the missing side. We need to be doing the same things over and over again. We need to label our triangle. Always label the hypotenuse first, then label A and B. Write out Pythagoras. substitute in our values, then think, do I need to rearrange? I can rearrange later on, but I need to understand if I need to rearrange or not. Am I looking for a longer side? Am I looking for the hypotenuse? Am I looking for the shorter side? These are things you need to constantly be asking yourself when you're answering these questions. Now, what I suggest you do now is, if you want a bit more practice, you go and watch Mr. Amison's video and do some practice on finding a missing side using Pythagoras. If you're feeling super confident and you want to do some harder questions, go on Corbett Maths or Dr. Frost and practice on there. Hopefully this has been helpful. Go off, be productive, and I'll see you in the next video.